off. Oh, what am I doing? Okay. All right, I'll just run this real quick. So just to show that it actually runs. So I have it print out the solution path once it's done, and then I can go back to verify that each step was correct and the cost and the depth are correct, right? And then I have it output some stats, right? So the nodes popped off, how many were in memory, whatnot. So as far as nodes go, I modeled it with the direction that the tile was moved, like how that tile got there, like the previous position. If that makes sense, I don't know how to explain it. This didn't use, had it before. The state is basically, I was trying to like put it in a set, so I needed to have like a struct container, but I ended up not doing that. But regardless, I just have the state, which realistically is literally just this with this operator. So this is like the default or whatever. I just did a 3x3 2D matrix. Successor function, that's like one of the important spots. Sorry. So let's go. So my successor is pretty easy. The way that I contain my children is just like in an array, and like when I'm going through, when I'm cycling through, when I'm cycling through, I I just go through that array, and if it's a null pointer, then I won't add it to either the queue or like the visited list or whatever. And then here's each of those like functions themselves. So what I do is I take, for right, like you can't move to the right if the 0 position is like less than 1 or greater than 2, basically, right? So that's what this conditional is, right? And then what I do is I have a overloaded constructor for the node, and I pass in like the parent's depth, the cost, the state of the tiles, and then like what their direction is, right, based on the function. And then I give it the right 0 positions. So then I copy over the state and then change the actual position of the tile and the 0 so that it's like the newer one, right? And then yeah, that's how I do that. So I have the goal checking, testing, copying the state, right? And then my functions, let's go to BFS just to show you real quick. I have no idea how long this is. So basically I just use a queue, right? You push the front, the start node onto the queue. I have this conditional, right, for an easy, medium, hard, just to make it easier on me. And then you do the successor function, right, for the front of it. You check to see if it's a null pointer at that position of the children array. If it's not, then you check to see if it was already visited, right? And this already visited is a deck that I have that I add to puzzle, right? If it checks, oh sorry, this is a function or definition. So if this is, it goes through the visited list, which is the actual deck, and sees if it's equal. If it is, then you return true. If not, false. Then you push it onto the queue, and then you push whatever that was onto the visited. I know it's not actually visited, but I named it that, and it's stuck. It's on all my functions. So it's just to show that it's been pushed onto the queue, right? Or onto the, yeah, it's like somewhere. It's already been seen at some point. It should be called seen. Then I check to see if it's the goal. And then if it is, what I do is I have the solution path, which I think is just a queue too. No, it's a stack. And then I keep going, iterating through the parents until the parents, it doesn't exist, right? There's a null pointer, which means that's the first one. And then I basically dequeue or pop everything off that stack to print it. That's how I get that print. So that's my BFS. DFS, basically the same concept, except I use a stack and then I pop at the front. this actually did not meet the time requirements. I know it works with easy, but it doesn't meet, like it finished in like 9 minutes or something like that. It was something ridiculous. So I think something's messed up in there, but I use a stack. Let's just make sure this is not, I can't tell. Okay, I'm wasting precious time. Uniform cost, same deal, but I just check to see, or I use a priority queue using this cost comparator. I have comparators for basically all the different more complicated ones. I have cost, the best, which is the incorrect number one, the A*1, the A*2, and my A*3, which is Manhattan distance times the actual tile value. And this one works phenomenally. A*2 doesn't work for some reason. I have no idea why, at least on hard. A*1, I just figured out why it doesn't work. And the rest, yeah, should work, I believe. So, or they all do work, rather. I think that they all have the same kind of structure. They just, you're using different priority queues, right? And then for the A*stars, I also have a check to make sure that, so if it's visited, it checks it, but it also checks to see if the cost, like if it's seen it, if the cost of whatever it's checking, right, for A*3, it's this, is less than what's already on the visited list, then it just replaces that one, so that it, and then, like, you know, removes the other one, so that it makes sure that it would be the best path or whatever. Okay, I think that's enough. I don't know if you're even listening to me at this point, but okay. Bye.